Hello. Okay, you should see the desktop. Can you hear me and see the desktop? You pull up the chat window. Is everything okay? Can you hear me? Can you see the desktop?
Yeah.
Yeah.
Okay, thanks. Looks like almost everyone's here. Okay, so we're going to keep on talking about loops today. We're going to talk about, we're going to start this section, we're going to do this section here and maybe have time to start this other section. And then next week we'll be doing nested loops too. So I'm not sure if we'll have time to start nested loops today. We're going to talk about loops and strings, and then probably and maybe start nested loops. And then for next week, there's a reading assignment, a little bit more about loops. It's pretty brief. These are very short sections. Actually, 4.6 is just a summary of the stuff about loops. So the reading assignment is a little bit more about loops, and we'll spend most of the next week talking about these nested loops. Okay, and we're also going to start reintroducing methods. So chapter 5 in this book is, we're going to return to methods. It's a short chapter with a few sections. We've talked about methods before, but we're going to talk about them again. And what we want to do is kind of like summarize everything we've done so far. Methods with for loops and if statements that use logic. So we're going to kind of combine lots of things that we've talked about in together. So this chapter is going to serve as kind of a bit of a review of what we've been done so far. Okay, so that's also, can start reading that also. Okay, all right. So next week will be nested loops. This summary, this stuff here that just summarizes the tail end of loops, and then I don't know if by the end of the week we'll start talking about methods again. We'll talk about methods as we talk about loops also. Okay, and then also I put a couple links to some problems at the end of the chapter on loops. So here's some problems that are these mixed up code problems about loops. They're very good problems to work on. Yeah, they're not very hard, yeah, but they give you a good sense of what kind of things we're doing. Then there's slightly harder problems on this page where you have to write your own code. Okay, there's a bunch of problems on this page. I asked you to do just a few of them, 4 of them. Those are the ones I recommend the most. You should do those as practice, 8, 12, 13, and 16. Okay, so do, here's number 8, for example. So you have to write your own code. They give you a little bit, they give you a little bit of code. Okay, well, actually in this case you have to fix the errors that is in their code. So some of them, like this one, you have to fix their errors. In other ones you have to write your own code, like this one just is blank. Okay, so the ones I told you to do, like 8, you have to fix their errors. Here's 12, they give you 1 line and you have to write the rest. And here's 13, they give you 2 lines and you have to write the rest. Okay, so these are a little bit harder than these problems. Okay, and then both of them are really kind of warm up to doing coding bat problems. So the real challenging problems, the ones that are really the goal, is these problems here from coding bat. So I'll give you a little bit more later on. Like these are involving if statements, and there'll be some more later on involving for loops. But these are the real problems to work on. These are the ones that are the real goal of what we're doing, is that you can solve these problems. So these are just warm up. The reorganize the code kind of thing, and the either fix their errors or just add a few lines of code. Okay, these are good practice problems. And then you definitely should be doing these. And if you have any questions about them, come to office hours or send me an email. But these are really, you should do 1 or 2, one of these every day or 2. If you did 1 of these every day or 2, that would be great. Okay, and that really is, that's your best way of measuring that you're absorbing what we're talking about, that you can do one of these every day or two. That would be a good goal. Okay? All right. Now, we're going to talk about loops and strings. Okay? We talked a lot last week about loops. So last week we did these things on like what is, how while loop is kind of like an if statement. An if statement says if this is true, then you do something. But a while loop says while this is true, do something. So after you do it once, you go back and check, is it still true? If it's true, you go do this, and then after that, you check, go back here. So you loop around. So notice that they syntactically look a lot alike. If Boolean expression do something, while Boolean expression do something, okay? And then there's the for loop, just gives you a slightly different way of writing the while loop. You write it as initialize something, test something. The test here is the same as the test here, but this gives you an initialize before the test, and it lets you increment the thing you're testing here. Remember, do something, better change this Boolean expression at some point, because if this thing never changes this thing, then you have an infinite loop. If this thing stays true forever, you're just going to loop forever. Here you make it a little bit more explicit. This increments usually what you're testing here. Usually when you write a for loop, you start off with a value like I equals 0. You test here like I is less than 10, and here you increment I. So that makes it clear what you're doing. So for loops are while loops written in a slightly clearer way. Then this do something doesn't have to change what's in the test, because usually it's this thing that's changing what's in the test. So that makes it easier to read. This is what changes this. And then down here, you could just do so whatever logic you need. But in a while loop, you have to be very careful that this somehow changes this. Otherwise, you're in an infinite loop. Okay, so that's what we talked about a lot last week. Now we want to start doing interesting things with loops. And what the book does is introduce the idea of loops and strings, which is a really good way to see how you can do things with loops. So I've got some examples on my computer that I want to look at instead of the examples in here. So I'm going to do some different, they do some examples in their code. So they do some examples in here. You should read their examples. And then let's do some other examples that are similar. Okay. So the key idea is we want to write a loop that goes across the string one character at a time and does something for us. So the idea is that the loop would be a loop that goes one character at a time. Remember the characters have numbers associated with them called their index. We start counting at 0, and then every letter in the string has an index. Okay, and we can what's sometimes referred to as walk the string. We can walk along this string using a for loop or a while loop and do something to the string. So here's a bunch of examples that do something like that. Okay, so here is a string, and above it I put a comment to duplicate what's in this picture over here. See how they put the indexes above the characters. Well, so there's index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But then to keep this one above the letter it is, I dropped the, so that's 10, 11, 12, 13, 14. So character 14 is the O. Character 15 is the N. And then character 17 is the E, the period. Okay, now there's 18 characters in this string, but position 18 is off the end of the string. Okay, so because we start counting at 0, it's kind of quirky. Because we start counting at 0, okay, there's 18 characters in the string, but the 18th position is off the string. Like over here, there's not 13 characters in the string. There's 14 characters in the string because we started counting at 0. So, and position 14 is over here off the end of the string. The length of the string, which is 14, is the position at the end of the string, right after the end of the string. That's going to become important to us. The length of the string is actually the position that's at the end of the string, right after the end of the string. Okay. Now, let me rewrite this a little bit. Here's one way to walk a string. I'm going to have a for loop that counts these indexes. So the for loop's going to start out with I equals 0. That's the first index. I is going to be strictly less than the length. That's this last index. See, I'm going to stay strictly less than 18. So I don't write less than or equal to here, because if I wrote less than or equal to, I would be hitting that position and there's nothing there. So the way we always write this is start at index 0. I go up to, but not including the length of the string. And the length of the string is this index right after the end of the string. And then I want to step through the string by ones. And here, I'm going to walk the string and just do something real simple. I'm going to print out one character. So I'm just going to print out the characters, one line. Each line of output is going to be one character. So substring from I to I plus 1 is one character. Because remember, substring starts at this index and goes up to, but not including this index. So if I go from I up to and not including I plus 1, I'm just printing out I. I'm just printing out one character. Okay. Now let me comment out this other code. We're not going to use it for a minute. Okay, so let's just run this. So we're going to loop through, we're going to walk this string here using a for loop. Okay, and visualize it. Okay, now we have to remember how for loop works. This is going to be practice in thinking about for loop. There's our string. Okay, then we enter the for loop. Oh, remember the picture for loop. So let me pull up that picture. Let me close these. Remember this picture here. Okay, we want to make use of this picture here. Okay. Okay, we're line 8, so we've just entered the for loop. But according to this picture, when you enter a for loop, you're at the initialize part. So right now we're about to do this. Okay. When I click the forward button, I'm actually not going to move from line 8, because remember here, after doing the initialize, I stay on that same line and do the test expression. So when I click the forward button, you'll see I appear over here. See, I just did that highlighted part. But I stayed on line 8. That's because I'm going from initialize to test. So now I'm about to do this part of line 8. So I'm still on line 8, and I made a step in my program, and I did this part, the initialize. Now I'm doing the test. Doing the test, 0 is less than the length of this string. So now this is going to be true. So I will go into the do this. The do this is line 10. Okay, so now I'm at line 10. Okay, so I'm going to do that. Okay, now after I do that, I go back up to here. So I'm going to go back up to here, but I'm going to go to this part of the expression. So now when I click forward, I'm going to go from line 10 to line 8. See, but I'm actually right there. How do I know that I'm right there? What are you going to see when I click forward? What do you see happen when I do this part?
I changes.
Yeah, I will change. See, I'm back to line 8, and I'm at this part. See, I'm following that picture to the increment. So clicking forward is going to increment I. There it is 1. But now I moved to this part. See, I stayed at line 8, but I moved from increment to test expression. Okay? So I moved from over here to over here. Okay? Now I'm at the test expression. 1 is less than the length of the string, which is 18. So this is true. So now I'm going to go to line 10. Okay? And now I'm in the loop. I'm going to go from line 10 back to 8, but I'm over here in 8. Forward is going to increment I to 2. Now I'm over here in 8. I'm over here, and now I'm going to go back to 10. Now, unfortunately, you notice that you don't see me moving from this part to this part to this part. Now, if we go back to edit code, I can actually make that happen. Watch. Originally, this thing looked like the following. I had each piece of the for loop on its own line. This is a little trick to get the Java visualizer to actually show us which piece it's on. If we put each piece of the for loop on it, nobody ever writes code this way. You never would want to write it this way in a real program. But this tricks the Java visualizer into showing us when it's there, and when it's there. So watch this now. We'll go to visualize again. Okay, so we start out line 6. We create the variable that's the string variable. Okay, notice I'm at line 8. I'm coming into the initialize part. See, I came into the initialize part. So go forward 1, and I'm going to go from initialize to test. And you'll see it go from line 8 to line 9, and it's going to create I. So see, now we see it. It created I, and it moved to line 9, the middle part. Okay. Now it's going to go from line 9 to this part here. It's going to go from line 9 to line 12. Okay. Now it's going to go from line 12 to line 10, because we're going to go from here to here. So now go forward. See, line 10. I went from line 12 to line 10. Now I'm going to go from, now I do the increment, and I'll see I change. Increment, I changed. Now I go from 10 to 9. Now I go from here to here. Okay, and now I'm in the loop here to here to here, here to here to here. And now I'm going to see the loop is 9, 12, 10, 9, 12, 10, 9, 12, 10. So now I'm in the loop. Increment, test, do something. Increment, test, do something. Now I'm in this loop here. Okay, so you can fool the visualizer into showing you which piece it's in by putting each piece on its own line. Okay, and then you can see that it really is doing the order as it's drawn in this picture. Initialize once. Notice we never go back to line 8. We never go back to line 8. It's only done once. You enter in at the initialize. You immediately go to test. Then you go to the do this. Then you go to the increment, test, do something, increment, test, do something. In this case, it's going to be 9, 12, 10, 9, 12, 10, 9, 12, 10. And you always leave from here. Okay, see, you leave when this thing is false. And so that will eventually will go from 9 to the end of the program. So let's just keep stepping through here. I equals 4, 5, 6, 7, 8, 9. And notice that on the output, I'm getting my characters one line at a time. Okay, so I'm getting my output one line at a time. See, we're up to 10, 11, 12, 13, 14, 15, 16. Okay, now we're near the end. I is 17. That is this last character, the period. We're about to print the period at the end of the sentence. Okay, so we're about to get to the end. So I is 17. 17 is less than 18 because 18 is the length. So we go down here. We're at 12. We print out the period. You can't, okay, you'll see, okay, now you'll see the period print. Print out the period, and that takes us back to I++. We do the increment. I is 18 now. Yeah, if we use that as an index, it's off the end of the string, but we don't want to use it as an index, but we check now, is 18 strictly less than 18? So we go forward. Now we're testing, is 18 strictly less than 18? No. So now we finally go not from 9, now we go not from here into here, we go from test outside of the loop. So now we're going to go out of the loop. And then I print a blank line at the end. So I went to the outside of the loop here. The outside of the loop will just print a blank line after the period. Okay, and then the program is done. Oops. Then the program. then there's just this big long comment for the other examples. Okay, so if you break the loop up like this, you can actually have the Java visualizer show you the pieces. Programmers never do that. Sometimes if these lines of code are very long, sometimes a programmer will write them like this. The initialize part, the test part, and the increment part. Sometimes they'll write them like that. But then your boss will say, if these are so long and complicated, you need to write them on 3 different lines, you probably ought to rethink your for loop. These things should not be complicated. 99 out of 100 times when you write a for loop, the initialize is simple, the test expression is simple, and the increment is simple. If they're really complicated and you need to put them on 1 line each, that's usually a sign that you might not be doing things right. So normally we would just have something simple like this, all on 1 line, the initialize, the test, and the increment. Make it easy for people to read so they can see, oh, you're starting at 0, you're going up to here, and you're incrementing by 1s. So that's a pattern for stepping through something. Starting at the beginning, going up to the length of something, going by 1s, stepping through something. Okay, so programmers always write it in 1 line like this, but then when you visualize it, it doesn't visualize as well because the visualizer shows you it just shows you kind of stuck on line 8, then you go to line 10, then you're stuck on line 8, but for a couple steps, then you're back to line 10, then you're up to line 8, but for a couple steps, then so it looks like you're bouncing between 8 and 10, and you are, but you're really bouncing from 10 to the increment part, to the test part, back to 10, back to the increment part, back to the test part, back to 10. And you have to remember that. You have to remember, when you write your own code, and you write your own for loops, you've got to remember that this is what's happening. That has to be very much what's in your mind, that you're going to initialize something, test it. If it's true, do something, then increment, then test again, then do something, then increment, then test again. Okay, and if because you have to put all these pieces together. There's 1, 2, 3, 4 pieces that work together. We're going to just start doing a little bit more complicated things in a minute. You've got these pieces working together. You have to see the flow of it to understand how it works. You can't just read from left to right and then read down here. It won't make sense on more complicated code to read this from left to right and then read what's in here, because that's not what it does. It doesn't go left to right. It goes here, 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 then back over to here, then backwards. Goes from right to left, then down, then over here, then right to left, then down, then over here, right to left. So you're reading from right to left, actually, not from left to right in this thing. So you can't read it like English. You have to get very used to reading it as a programmer. Okay, so now let's look at another example. Oh, now, the one we just did printed out all the characters in a string, just to do something, not very interesting, but just to do something. And this one does the exact same thing, but instead of getting the character using substring, you can get the character using char at. Sometimes it's better to use substring to get one character in a string. Sometimes it's better to use char at. We'll see examples as we go on. Substring has its advantages, like you could 2 uppercase it real easily or 2 lowercase it real easy. Char at has advantages because it's a little bit easier to compare these sometimes. We'll see, you can compare this character to another character. You can do things like ask, is it a question mark? You can ask, is the char at I equal to question mark? If you do that with substring, it's a little bit hard. You can do the same thing, but here you would do dot equals quote question mark quote. Is that character equal to question mark? Okay. But down here, you can do even more interesting things. Down here, you could ask, is it less than, say, X? So that means, is it a character like A, B, C, D, E, F, G that's less than the X character? Okay. That's real easy to do with char at. You can just say, is my character less than some other character? It's a lot harder to do that with strings. It's tricky to do comparisons with strings. It's a lot easier to do comparisons with characters. Like, say, is one character greater than another character? So sometimes you want to use substring to get a character. Sometimes you want to use char at. Okay, so here, if you run these, they just do exactly the same thing. I'll just go here to the last, look at the output. Both of them just printed out all the characters in the string. See, there's where the first loop ended at that blank line, and then it just printed out all the characters in the string again. But the first loop got the characters using the first loop used substring to get one character. Notice it's a little bit quirky. Substring from 0 to I plus 1. I'm sorry, not that one. I'm sorry. Substring from I to I plus 1 is one character. In a way, this reads a little bit error. The character at I. Okay, that actually reads better, but it's a different kind of variable. This gives you back a character, this gives you back a string, and that really matters. Okay, sometimes you want a string, sometimes you want a character. This one reads a little nicer, this one reads kind of quirky. The substring from I to I plus 1, so that's one character at, from I up to, but not including I plus 1, so that's just the character at I. But the character is a string. It's got double quotes around it. Here it's got single quotes around it. Okay, so you can sometimes use substring to get a character and sometimes use char at, and sometimes one is better and sometimes the other one's better. Okay, now let's look at another thing we could do to walk a string. Let me block out the first two. We've done the first two. Let's do the third one, and I'll block out what comes after the third one. So let's just look at the third one, the third example. Okay, it's a slight variation on the one we just did. Now it's going to ask for the substring from 0 to I plus 1. Okay, what we did was substring from I to I plus 1. Okay, now think in your mind, can you figure out what does this one do that's different? What's the result going to be? Try to puzzle it out. See what we can think. Instead of going from I to I plus 1, I'm going to go from 0 to I plus 1. This printed out one character per line. What does this print out?
2.
The I is walking.
Like,
pardon me?
bigger and bigger sections of it.
If somebody's saying something, I can't hear you. Your volume's probably not loud enough. It sounded like somebody was saying something.
Can you hear me now?
Yeah,
It's gonna keep printing out bigger and bigger sections.
Yeah, it's gonna always start at the beginning, right? But then it's gonna go farther and farther down the string. So first it's gonna print from 0 to 1, then 0 to 2, then 0 to 3, then 0 to 4. So you're gonna see like a ladder or a staircase of longer and longer strings. Okay, and this is okay. So let's look at the output. Okay, I'm just going to go to the end so we can look at the output. So instead of tracing through it, I'll just jump to the end. Okay, and then here's the output. Notice I can't make that box bigger. I can make this box wider, which is nice, but for some reason they won't let you make this box taller. See, their interface is not the world's greatest interface. I can scroll, but I can't make that window taller. Okay, so I started out with H, then HE, then HEL, HELL, HELLO, HELO hyphen, HELOT. See, so I got longer and longer, kind of like a staircase of the strings. Okay, all right. So make a little change in the code, and we get a different kind of output. Okay, so we're going from the beginning to farther and farther in the string. Okay. So notice that the key idea is that we're still walking down the string. What we're walking is the end point. So the loop was creating the idea that go from beginning to the first character, from the beginning to the second, from the beginning to the third, beginning to the fourth. The loop was changing where we stopped. So as it looped, it lengthened the stopping point. It made the stopping point a little bit farther down the string. Okay, so the loop was controlling where we stopped. Okay, all right. Now let's look at the next example. Okay, so here's the fourth one. Okay, now the substring is substring I. Well, first of all, what's substring I mean? This is the other version of substring. It takes one parameter, not two parameters. What does this one mean? Go ahead and answer. Answer questions. You want to practice answering questions. You know, in another year, many of you are going to want to get internships. Many of you are going to want to apply for different kinds of things. You will be asked lots of questions. Practice now. Practice now in answering them, because you will be asked them in job interviews. I mean, if you know, after your freshman year, you can apply for an internship. Certainly after your sophomore year, you can apply for internships. It's pretty common. Internships are really valuable, but people test you when you get interviewed for internships, and they ask you questions. Tell me what this code does. Tell me what this does. Now's the time to start practicing that. You know, please answer questions. You know, push yourself to answer, because you need to practice. You know, the pressure is going to be there in a job interview even more than it would be maybe in a class, and you know, it's what you want to get used to. You know, you know, think about code and talk about code. That's what our goal is, because if you're especially if you're a computer science major, that's what people are going to ask you to do. You know, they're going to set you in front of two or three other people, and they're going to just start asking you questions, tell you to write code. They're going to ask you, what does this code do? Our students come back from these interviews. I talk to them all the time. That's exactly what companies, you know, they do this. So now remember, what does that version of substring do? Substring I does what?
Finds the first instance.
Oh, I can't hear. I heard a voice, but I couldn't hear what. You probably, maybe your mic's not up high enough.
It like finds the first instance of I.
Let me check if okay, I think my speaker is set a little too low. Okay, go ahead and talk again.
It like finds the first instance of I.
No, it's not the find one. No.
Does it return everything after I?
Yes. Yeah, it turns everything after I, not including the well, it's from I up to the end of the string. So this is where it starts, and it goes from there to the end of the string. See, this was the one that went from the beginning to somewhere in the middle of the string. This is the one that goes from somewhere in the middle of the string up to the end. Okay, so from 0 to I plus 1 is from beginning to middle. I by itself is from middle to end. So now what's this going to do? Now, okay, think I starts at 0. So when I is 0, what do you print out?
The whole line.
Yeah. Now then I goes to 1. What do you print out?
Everything after 1.
So all but the first character. Now I goes to 2. What do you print out?
It'll just keep getting shorter and shorter.
Yeah, they keep getting, but what do you, it's shorter and shorter tail end of the string. Okay, so we're going to see the shorter and shorter tails of the string. Okay, we could do shorter and shorter fronts of the string, but we're going to do shorter and shorter tails of the string. So it's going to always be from somewhere to the end, and it's going to get shorter and shorter. Okay, so let's visualize it. Just go to the end, watch. Okay, see? The whole string, a little bit shorter, missing the first letter, a little bit shorter, missing the second letter, a little bit shorter, missing the third letter. Now notice that's different than if I shorten it by dropping the period, then dropping the E, then dropping the N, then dropping the O. Okay? Yeah, we haven't, that's one we didn't do. Okay, now let's go back. Compare the two we just did. Okay, so now I'm going to do this one, things got longer. This one, things got shorter. This one got longer starting at the front. This one gets shorter, but always going towards the end. Okay, so look at the output. Okay, it's got kind of a flaky interface. Okay, there is starting at H, getting longer and longer and longer and longer and longer and longer until we got the whole thing. Now we got the whole thing. Now it gets shorter and shorter and shorter, but by chopping off the fronts. Okay. Now here's a puzzle. What if I wanted to do the opposite of what this one did? I want to keep the HE at the front, but I want to shorten it by chopping off the period, then chopping off the period in the E, then chopping off the period in the E and the O. How would I go back and make this one get shorter, but keeping the front? This is a little bit tricky. How would I go from, what would I do? I would go from the front to not quite the end. How might I write that?
Can you do I minus minus?
No, because I minus minus still takes me from there to the end. So I'm not going, see, wherever I is, I'm going to the end, but I want it to go from the beginning to not quite the end. See, this one went from the beginning to not quite the end, and I want to go from the beginning to not quite the end, but instead of getting longer, I want to get shorter. Okay, so you're right about minus minus. Something has to decrease, but that's the end. The ending has to decrease. But what about the beginning?
Could we start it at 0?
Yes, because you always
and
want to
then
start.
change our I value to be our very last. I think it was what, 18 characters, and then have our condition I minus minus.
Careful. Try it almost. There's the end. 18's the end.
Would you use like the string dot length?
Well, okay, I should write string dot length. Yeah, I wrote 18, but you're right. Yeah, 18's a bad thing to write. So let me write it as s1 dot length. Okay, there's the 18. Okay, I don't want to go up to 18. What do I want to go up to?
Can you do minus 1?
Minus 1, but that doesn't change. See,
Minus I.
minus I, yeah. See, that changes. So now it's going, when I is 0, it goes all the way up to the end. Then when I is 1, it goes up to 1 less than the end. Then when I is 2, it goes up to 2 less than the end. Okay, so let's try this. Go from the beginning up to the end minus I. See what happens. Okay, let's see. Now, do we get what we want? Okay, looks pretty good. There's HELO up to the period. Drop the period. Drop the E period. Drop the NE period. Drop the ONE period. Okay, there, see, down to H. All right, kind of nice. Okay, so notice that that was by, I wanted to go, the first loop went from the beginning up to somewhere in the middle, but it was increasing the place in the middle. So the endpoint kept marching to the right. Now I go from the beginning up to well, the end minus something, but the minus thing is growing. The I is growing. So then this would be, moving the right end point to the left. It's length minus I. Okay. All right. So now I could do this another way. Suppose I really thought this is too weird. Okay. So here's another way. Watch another way I could write this. Okay. What I really want is this number here to march down 18, 17, 16, 15, 14, 13, 12, 11. Okay, I want this number to count down, right? Should start at 18 and then count down. Let's make this a countdown loop. To make this a countdown loop, you do, here's where the minus minus would go. Oh, I'm sorry, I need to go back to edit code. Okay, make this a countdown loop. Well, you make this a countdown loop by doing that. But if it's a countdown loop, where should it start?
At the maximum, 18.
S1, and instead of writing 18, I'll make it so that it works with any string, S1.length. I could put 18 there because the string we're working with has length 18, but then it wouldn't work if I changed the string. So I want to be careful, and I'll say I start at the length of the string, count down, but when do I stop?
At 0.
At 0. So I want I greater than or equal to 0. I want to count down from 18, 17, 16, 15, 14, 13, 12, down to 0. Okay, but now I change what's here. If it's a countdown loop, I go from 0 to I. Now it's a little bit easier to read. I'm going from 0 to I, where I is counting down from the length to 0. So I'm getting shorter strings because now I'm counting this one down. Now the answer, this is going to give me the exact same output the other one did. Let me actually do something here. This was our countdown loop. And here's just another version of it. So we can compare the two of them side by side. Okay. So here was the countdown loop by subtracting i's. So there's the countdown, but that doesn't look like a countdown loop. It's a little bit harder to read because I is counting up from 0 to length, but then you're subtracting I from the length. So this is, it's written kind of quirky. You're counting up, but counting down. You're counting up here and then forcing a count down here. So somebody might say, well, then you shouldn't have written it that way. Why not just make it a countdown loop? Start at the length, decrease down to 0, and just take the string from 0 to I, where I now is counting down. So let's check that this works. Oh, what did I do wrong? I forgot a parenthesis somehow. Okay. Okay. Now let me just go look at the output. Okay. There's our first countdown loop. That's the one we had before. And now here's our second countdown loop. It works just as well. See, it does a nice countdown from the right end to the front. And it's probably a nicer way to write it. Yeah. Now we got this countdown loop pretty much looking like a countdown loop. Notice that this is correct. They're both correct. Yeah. If this was a homework assignment, this would be worth just as many points as this one is. But if this was a code where you're working with people, when you're writing code in an organization, there's always the question if you've written the code as clearly as possible. Not just does it work, but have you written it clearly so that a year from now, when somebody has to look at it, they don't need to scratch their head and think too hard about it. Have you made your code as clear as possible? This does what we want. This does what we want, but this one's clearer. This one, yeah, we're really counting down. We're counting. This one here, this I is a countdown to 0. Okay, and this one, this is not too bad. But notice that I'm counting up and then counting right back down. That's a clue that it's really kind of flaky, because this guy counts up, and then this guy's forced to count right back down again. Because you take the length minus I, so that result goes 18, 17, 16, 15, 14. So why not just make I count down? 18, 17, 16, 14, 13. Okay, so notice how we're starting to see interesting things here. We're starting to see a little bit about how we can write these things in more than one way even. Okay, all right, now let's go to another example. Okay, I want to block out the ones we're not doing and just keep the one we're interested in. Okay. What I want to do is, I didn't put a comment in here, but what I want to do is I want to walk this string and replace every hyphen with an underscore. So I want to do a modification of the string. As I walk the string, I want to modify it. This is real common. This is, lots of code, massive amounts of code is in the real world is doing this, walking a string and making little changes into it. Okay, so here I'm just going to make a change. I'm going to, if I find an underscore, I want to replace, if I find a hyphen, I want to replace it with an underscore. Okay, and notice that I'm going to write it as a while loop. And then down here, I'm going to rewrite it as a for loop. So I'm going to do this problem twice. Once as a while loop and once as a for loop. Okay, so while, now notice that, remember, while loops, while this is true, do something. Okay, now the idea is while there is a hyphen in the string, while there's a hyphen in the string, replace it. Okay, that's the logic. While there is a hyphen, find it, replace it. Okay, now why is this one what I want it to be? It says, the question is there a hyphen in the string? Well, it says index of hyphen. Now, what if there is a hyphen in the string? What does index of give you?
A number.
And what's that number represent?
The index of
Yeah,
the
yeah.
letter.
So this hyphen would give you back 5. Okay, so now indexes are always numbers that are positive because there's 0, 1, 2, 3, 4, 5. What if there is no hyphen in the string? What is index told? What is rule for index? If you can't find what you're looking for, what answer does it give you?
-1.
-1. So notice that that's a binary answer. Positive is yes, negative is no. So if the question is there a hyphen in the string? And the answer is yes or no. From the point of view of index of, the answer is positive or negative. Positive means there isn't a hyphen. Negative means that there isn't a hyphen. Now it's actually telling me where the hyphen is, but I'm going to do that over again now to find where the hyphen is. So then I call index of a second time to find out where the hyphen is. So I'm doing the code in maybe not the most efficient way. So I'm calling index of once to ask, is there a hyphen? The answer is binary. Positive means yes, there's a hyphen. Negative means no, there's a hyphen. And if there's no hyphens in the string, I should just quit. There's nothing to do. Okay. So while there's a hyphen, well, okay, now do it again. Find the index of the hyphen. I know there is one. Find its index. Now notice that we're going to use the kind of things we did above. If I want to get rid of that hyphen and replace it with an underscore, what I want to do is take this part of the string and keep it. And I want to take this part of the string and keep it. And I want to replace this part here. So notice I want to break the string up into 3 pieces. This should sound familiar, very much like your homework assignment. I want to break the string up into 3 pieces: the part before the hyphen, the part after the hyphen, and the hyphen itself. And I'm going to replace the hyphen with underscore. There's the part before the hyphen. See, I is the index of the hyphen. So this is everything from the beginning up to, but not including I. So this is everything up to, but not including the hyphen. This is the substring from, well, why did I put it I+1 here? This is everything after I+1. Why did I put I+1?
Because we don't want the hyphen. Which
Yes,
is
I'm
I.
skipping over the hyphen. And then here I'm just splicing in an underscore where the hyphen would have been. So I'm splicing in the underscore. Everything before the hyphen, everything after the hyphen, because I is the actual location of the hyphen, and splice in between them an underscore. Okay, so find where the hyphen is, get what's in front of it, get what's after it, splice them together with a underscore in between. And then when you've removed one hyphen, you loop up and says, is there another one to do? And then when you've removed that one, you loop up. Oh, notice how I'm replacing S1 with the new string. So S1 is now replaced by that modified S1. So the new S1 is missing one of its hyphens. Eventually, what's going to happen to this loop?
There won't be any more hyphens. They'll all be replaced with the underscores, and it
Right.
will be
So
done. It'll
this
print it
guy
out.
will eventually be false. See, this loop is, this part here is being modified by the loop, because as the loop removes hyphens, eventually this one's going to eventually say, no, there's no more hyphens. In this string, how many times does this loop loop?
2 times.
2 times. Yeah. It'll evaluate this thing 3 times, and it'll be false. It'll be true twice, and it'll be false once. So it'll loop 2 times. It'll check this condition 3 times, and it'll loop 2 times. Okay, let's watch it run. Let's actually watch it this time. Okay, we're down here while. Is there a hyphen in this loop? Yes. So, okay, find the index of the hyphen. 5. Well, you can check 0, 1, 2, 3, 4, 5. Yeah, that's, you start counting as 0, that's 5. Okay, so now I've got the index is 5. Now, this will all happen at once. I can't see this pieces, but Java's going to break off the first part of the string, break off the second part of the string, and splice this thing in between. You'll see this guy change now. See, the hyphen turned to an underscore. Okay, now I go back up. Now, is there a hyphen in the string? Yeah, there's still one more left. Where is the hyphen in the string? It's at character 8 now. Replace it. Loop back up. Now remember, we're up here for the 3rd time. We've gone through the loop twice. We're up here for the 3rd time. But now there's no hyphens in the string. So that's going to be false. And I print a blank line. Okay? So it looped 2 times. It executed this thing 3 times, but it looped twice. Okay. Now let's do the same thing with a for loop. You could do, it's, as you learn the program, one of the things you learn to judge is, should I use a while loop or should I use a for loop? And there's no easy answer to that. Sometimes while loops are clearly better, sometimes for loops are clearly better, and sometimes it's a toss-up, you can use one or the other. Okay, so first, let's see how we would do this with a for loop. My for loop idea is walk the string and ask, is H an hyphen? No. Is E an hyphen? No. Is L an hyphen? No. Is L an hyphen? No. Is O a hyphen? No. Is hyphen a hyphen? Yes. Replace it. Is T a hyphen? Is O a hyphen? Is underscore a hyphen? Yes. Replace it. Then walk to the end, because you don't know, there might be more hyphens. Check for that one. Check for that one. So we're going to do a walk the string and check every character one at a time. And every time we check a character, now that means an if statement now. So what that means is walk the string, just like we did before. Start at I equals 0, all the way to the end, stepping by 1, and then ask yourself, and here I use char at, because I want to do a simple comparison. is the char at I equal to a hyphen? Okay. I could have used substring here. I could have used substring. It's just like we did over here. I could use substring to find a character, or I could use char at to find a character. If I used substring here, let me actually write it for you using substring, show you how I would change it. So here's the version of that one using, instead of using char at, I would do substring. If I want to look at one character, I do I to I plus 1. But then I want to ask, is it equal to? And then I have to put double quotes around the hyphen. And now it's the same thing. This pretty much means the same thing as this. Some programmers prefer to write it this way using equals. Some prefer to write it this way using char at. Notice that char at gives me a character. And since that's a primitive type, I use double equal. Substring gives me a string. Since it's a string, I have to use equals. And then I have to compare it with another string. Details, it's all about details. Substring gives me a string, and so I have to use equals. Char at gives me a character, primitive type, so I can use equal. Okay. Now, if I've got a hyphen, if I have a hyphen, now this line of code is exactly like before. Replace it. That's exactly the same line of code. Just replace it. Okay. So if there's a character, so walk the string. If I find a hyphen, replace it. Okay. Now remember, this thing looped 3 times, right? How many times does this thing loop? How many loops around does this one do?
18.
18, because like we said, it's got to walk the whole string. It's going to go here and say, is H a hyphen? Is E a hyphen? Is L a hyphen? Is L a hyphen? Is O a hyphen? Is hyphen a hyphen? Yeah, there's one I'll replace. So it's going to walk the string 18 steps. Okay, so it's going to do 18 loops. Okay, this one only did 3 loops. Does that make it better? Turns out we'll come back to that question. It turns out to be an interesting question. This one did 3 loops. This one does 18 loops. You might think this one's faster because it did fewer loops, but that's not true. Okay, it actually is not true. But let's watch this one work and see that it really does the right thing. But we'll also see that it needs to do 18 loops. It has to walk the whole string. Okay, so here's the while loop. 1, 2. That's it. 2 loops, 2 times around. Okay, now here's the for loop. Oh, I can't do that now. Oh, yeah. Why can I not do this for loop example? What's wrong with it now? I kind of what's wrong with doing this thing over again?
Because S1 is being changed to
Yeah, by now there's no
S1.
by now there's no more hyphens left in S1. So let's go back to the code and comment out the while loop. Because by the time we get to here, there are no more hyphens left in so let's get rid of the while loop. So let's just go straight to the for loop example. Okay. Okay. So let's just do our one for loop example. Okay. Now here we are at the for loop. Now let me just fast forward through it. 1, 2, 3, 4. See, now I'm already up to the 4th iterate through 4. This is the 5, 6. You notice I'm looping. Okay. Now notice I've gotten both of the hyphens, but I'm now at character 15, which is somewhere over here. I don't remember which one it is, but I still have more. I have to go all the way to the end of the string. See, now I'm at 17. Now I'm at I equals 18. That was past the end of the string. Now I'm done. Okay. I had to loop through I had to loop through every character. Okay. Now let's go back and watch it more carefully. Okay. So we enter here and create I. So we created I. Now we check that I is less than length. It is. Now we check, is the char at 0 a hyphen? So now we're checking, is the H a hyphen? The answer is no. So we skip the body of the if statement. We're at the end of the for loop, so we're back up here. So we're going to go from 49 to 47 because that was a no. Now, where are we at 47? We're over here in increment. See, we're over here at increment. So now I is going to change to 1. Well, I'm still at 47, but where am I now? I'm at the test. 1 is less than 18, so this is true. So now I'm back. Now I go to 49. Now, is the char at 1 a hyphen? That's the E. No, it's not a hyphen, so skip over it. Now I'm back over here. Okay. Now I'm back over here. Okay, but I is 2 now. Now I'm back here. I is 2. I'm at the L, the first L. That's not a L hyphen. Okay, now I'm going to be at the 3, which is the second L. That's not a hyphen. Now I have I equals 4. That's the O, which is not a hyphen. Okay, now I equals 5. Okay, I equals 5, HELLO hyphen. That's the hyphen one. See, I'm at the hyphen now. So this line now is going to get rid of one of the hyphens. Okay, it's an underscore now. And now I move on to the T. Okay, the T is not a hyphen. Increment I. The O is not a hyphen. Back to incrementing I. And now I'm at 8, which happens to be the second hyphen. So now I'm going to go here, replace the 8. I is 8 now. So the first substring is everything up to the O. This substring is over here, so from the E on, and then I put this underscore in place. Notice you might think I'm done because I got rid of both the underscores. Why can't I quit at this point? I'm done. You know, I got rid of both the underscores. Why doesn't this thing just quit somehow?
Because I is still less than the length of S1.
Yeah, but what's the logical reason? You know, I've gotten this far in the string. I've gotten rid of the hyphens. Why can't I quit?
The condition is still true.
Well, but think of it. You know, somebody asks you, well, yeah, I know what it can do. But just somebody's arguing with you. You got rid of the hyphens. There's no more hyphens. Why are you still looping? They're claiming you're not a good programmer. You got rid of the hyphens. You're still looping. You seem kind of dumb. Why are you still looping when there are no more hyphens? What do you answer them?
How do you know there's no more hyphens?
Yeah, how do you know? Like, how do I know there's no more hyphens? How do I know there's no more hyphens? How do you know there's no more hyphens? What are you using to see that?
Well, we can see it in the updated version of S1.
Yeah, we see it with our eyes, right? But our eyes are not a logical piece of software. The software doesn't have any way to look, how does it look forward and know there's no more hyphens? Only by running our code. The answer is that the software can't know there's no more hyphens until it's done what?
Running all of its loops.
Yeah, until it's looked at every single character, right? See, it's not that it has to run all its loops. It has to look at every character, because what if there's a hyphen over here? Like I could easily go back here and put a hyphen right there. So now after the second hyphen, there is another hyphen, but the code, when it's halfway through the looping, it has no way of seeing what's up there. You have to step through all the loops. So because people forget this kind of stuff. People will argue with you on this, that they see something with their eyes and see it's true, and they think the code sees it too. There's no more hyphens. Why are you still working? I mean, I'm smart enough to see that there's no more hyphens. Computers are supposed to be real smart. Why doesn't the computer know there's no more hyphens? And computers don't see things. They have to use logic. So the program has to finish stepping through all the spaces, every character in the line, to see that there's no more hyphens. We see things that are, and this actually causes a lot of pain when people are learning programming. They forget that what they can see that's obviously true, the code doesn't see until it's iterated all its logic. The program needs to do all the logic. It's need to look at every single character to know that there's no more characters. Okay, so even though there's no more hyphens, this loop doesn't know that until it's finished the loop, because at that point it will have looked at, right there, it'll have looked at every single character and compared it to hyphen. So it doesn't know until it gets to the end that it's exhausted the string, and actually there are no more hyphens at that point. Okay, so that's kind of a subtle question. And you will, especially when you do more complicated stuff, people will think, wait a minute, it's obvious that something is true. Why doesn't my code realize it? And it's because your code doesn't have a brain and it doesn't have eyeballs. It has no brain and has no eyeballs, and that matters. The code is dumb as can be. It has to step through things step by step by step, and it has to ask questions. It has to keep asking questions with if statements and things like that. So it doesn't know that there's no more hyphens until it's actually asked. Now, that begs the question of, let's go back over to here. Why did this thing only loop 3 times? Which is better? If this thing only needs to loop 3 times, and this thing needs to loop 18 times, a lot of people are going to tell you that this is better. But I'll tell you that this one's actually better. And I'm right. Okay. Does anybody, why is it, think about this one. It loops once, it loops a second time. On the third loop, there's no more hyphens. But how did it know that?
Because it searched for the index of a hyphen and it didn't find any.
So it had to do what? It had to do what? What did index of actually do when you asked it for the index of hyphen?
It had to run through all the characters or indexes of the string 3 separate times, whereas the other code just did once.
Exactly. So it actually did way more work than this thing. This thing, every time you ask it to find a hyphen, has to start at the beginning and scan through and look for a hyphen. Then when it stops. Then after it's found the first hyphen, it has to start at the beginning and go and look through everything to find the second hyphen. Then after it's found the second hyphen and it's gone, the only way it knows that is by walking the whole string again. So every call to index of walks the whole string. Now, here's what I'm going to do. Okay. What does this while loop do? You start here, you ask index of hyphen. So what does index of do?
It walks through the string until it finds the hyphen.
Which is almost all the way at the end, the second to the last character. So it walks almost the entire length of the string, finds that hyphen, and tells you about it. Then you replace it as an underscore. All right. Now you get back up here and you do this again. What happens now?
It walks the whole string and then
Finds that
Mhm.
one. Yeah. And then replaces it, right? Then it goes back up here and does what?
the whole thing.
Walks the whole string again, but this time, the third time it walks the string, what does it find out?
There's no hyphen.
There's no hyphen. Okay, now what does this guy do? Go back, our example would be this one. What does this guy do?
It looks at one character at a time.
So what's the punchline? What's better about him than this one?
He doesn't run the code the characters 3 times. He only
It
goes
only
through it
scans
once,
the characters what?
1 time.
One time. In fact, it turned out to be 3 times faster than this one on this string. On this string here, the for loop was 3 times faster because the while loop walked that string 3 times. Now, you have to imagine that string is a Google string and it's 1 billion characters long because that's what real computing is about these days. You don't walk strings like this anymore. You go work for Google and they say, well, our strings are 2 billion characters long. Okay, and they do. Everything on Google scale is in the billions. So this thing walks the string that's 1 billion characters long 3 times. So it does 3 billion steps. This thing does 1 billion steps. It's 3 times faster. Now, on the other hand, I could do the following though. What if I did that? Which one's better, the while loop or the for loop? How do they compare now?
The while loop would be faster because the while loop, when it finds the hyphen, that would stop.
Well, it finds the first hyphen and replaces it, right? That's 1 time through the loop. But it found the hyphen right away. Second time through the loop, what happens?
It finds the underscore and then the hyphen and then replaces
right
it.
away. Okay. Then third time through the loop, what happens?
It runs the whole string.
The whole string. What does the for loop do?
Just does it once.
Okay, which one's better?
The for loop.
For loop.
Why? Okay, my answer is they're the same. Does anybody agree? My answer is now they're the same. Maybe not quite exactly the same, but from my point of view, they're the same. Can you see? Why would I say now they're the same? The for loop always does the same thing. The for loop walks the string from beginning to end 1 time. That's what it always does. But in this case, what does the while loop do? Go back and think about the while loop. It looped 3 times, but what did it do on the first loop? Found a hyphen right away. What did it do on the second loop? Found the hyphen right away. Then what did it do on the third loop? Walk the string. It ends up doing a tiny bit more work than the for loop, but hardly enough to make a difference. Because it found that thing at the beginning and then it found that guy at the beginning. So if the hyphens are at the beginning, they're essentially the same. But if the hyphens are at the end, then the while loop's way worse than the for loop. What if the hyphens are in the middle?
And then the for loop's better.
A little bit better, a moderate amount better. Yeah, the for loop is clearly better by a moderate amount. Kind of depends on where the hyphens are. If the hyphens are more towards the beginning, well, then that doesn't hurt the while loop so much. If the hyphens are towards the end, it starts hurting the while loop a lot. Okay, what we're talking about now, there's actually a section in the book. Oops. Yeah. This is referred to as loop analysis. You're analyzing the loops and you're thinking, what are they doing? You're analyzing the loops. You have a whole course in this next year on what's called data structures and algorithms. You'll spend a whole course analyzing loops and more important things than loops. The question becomes, can you really tell me whether this one or this one is better? And if you think that this one's better, why? What makes it better? Or this one, when does it do okay? Like, when is it as good as this one? When is it worse than this one? The answer here is, if the hyphens are at the beginning of the string, that doesn't matter. If the hyphens are at the end of the string, it really hurts the while loop. And the while loop is pretty much slower than the for loop. The for loop's better because it's guaranteed to walk the string one time only. Okay. This little problem here is a favorite little interview question. This is an example of an interview question. They ask you, which one of these is better? Why? They give you 6 lines of code. Can't be too hard, can it? 6 lines of code, and they will ask you, which one of these is better? And by the end of this course, and after you've had the data structures and algorithms course, that's what they're looking for. Can you look at that code and tell them why the for loop is better than the while loop? Even though they do exactly the same thing. The performance of the for loop is going to be better than the performance of the while loop. The for loop's going to loop a guaranteed number that many times. The while loop could loop way more than that. Okay? The while loop depends on how many hyphens there are. Yeah, if the string is nothing but hyphens, the while loop's going to take a long time to do its work. Okay, that's referred to as loop analysis, and eventually you're going to look what's called algorithm analysis. You'll replace the word loop with algorithm, and you have a course on algorithm analysis. And it's all about this idea that tell me how many steps this thing did. Tell me how many steps this thing did. You know, and that's an important skill. You know, and that's actually what we're leading to. You know, can you write the code and then can you analyze the code? Can you make the code do what we want it to do? Then maybe rewrite it and then explain why the rewritten one is better than the other one. Okay, or we've gone out of time. But this is the kind of thinking that's going to play a bigger and bigger role as you learn more about programming. Okay, it isn't enough just to get the code working. It's also a matter of, like, can you justify that one of them is a little bit better than the other? Right now, what's important is that you can read this and tell me that they do the same thing. Okay, first, this and this do the same thing. They replace hyphens with underscores. From that point of view, this is just as correct as this one is. And then the more sophisticated thing is to then analyze them and say, oh, the for loop's actually a little bit faster than the while loop was. Okay, all right, so we've run out of time, we quit. So if you have any questions, always send emails, or ask for, you send an email or ask, oh, there'll be another program assignment up there pretty soon. There isn't one there yet. So there's still not a new homework assignment up there. So there'll be a 4th homework assignment up there by the end of, hopefully by the end of the weekend, real soon. Okay. So, and then that homework assignment will involve things with if statements and, start building up what we, start using what we've been talking about lately in a homework assignment. Okay. All right. So anybody have any last minute question? Anybody have a question? Okay. So have another nice weekend, and we'll meet again on Tuesday of next week. So I'll end the meeting here. Have a nice weekend. Bye.